Hi, Ravi.
Hello.
I'm good. I happen to I happen to join today because of Barshan. So like I always think like I have to join, but somehow I miss the timing. Like I can remember it after like 1 hour the meeting has completed. So today Barshan reminded me.
Yeah, that's good. There's Kavya. Okay, hello, Kavya. We'll wait for a few more people to show up. Hello, Jesse. I guess we can start. Jesse, did you have thing? Well, we're waiting for Barshan. Usually gives his update first, so we don't have him right now. So I don't know, Jesse, if you wanted to start.
Um, I'll really say a few things. I spoke to Barshan a little bit earlier about some other stuff. Um, it's a super busy week and a busy time. I don't know if any data and direct folks are going to join this week, but we had a first meeting this week, and it was quite good. And I have a lot of hopes and good times ahead about that. Um, I can I'm currently at a cafe, so I may not have any big things to say for a little bit. Barshan's here
Okay.
now to start with that. But it's been a very 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 busy full week, um, and a lot of um, a lot of interesting things in terms of things that I'll mention. One of the things I definitely want to mention later is a comment that came up on LinkedIn. I'd like Ethan Mollick for certain insights about technology, and there's stuff that he mentioned about interviews, things that might come up um, during an interview now about dealing with like AI or technology at your job. So I'll talk about that later. But otherwise, I'll pass the mic to you or Barshan or whoever else wants to talk about things.
All right. Yeah, Barshan. Hello.
Hello, am I audible?
Yeah.
Should I give an update?
Yeah, why don't you go ahead and give an update this for this
Yeah,
week?
so so I prepared some slides also. I'm done with the model, which I was supposed to do for the next 3 weeks. But I just went through the paper, and I just copied the paper's architecture itself and prepared the model. So I just presented so to show the different modules. One second. This was what was planned for this week. I was supposed to write a new lineage and graph initialization function, which was the EM, and I must have built the attention module, and and implemented the node importance and scoring and the graph decomposition strategy to generate the nested subgroups. I'll explain that in the next slides. So I had these plans last time. I didn't get time to look through the Mamba 3 architecture because I had to build this one. So I'll just go layer by layer. I'll reference the script as well. So this was the data layer which I already presented previously, but I just kept it in the slide so that I could go through the whole thing at one go. So so the raw input was epic CSV files, which has the column, cell, time, XYZ, which are the distance and the size on the plot. These are the 5 features that I took in, and then we have a build like the two. We're having a data loader which divides which has two modes, which was local and global. So then we have a fixed X tensor, which is in the shape of n comma d comma t, which is n cells and the 5 features and the time steps, and leaving the dead and unborn cells as 0, so that we can predict them later in the uh, functions. So after that, we have a Boolean alive mask function which tracks which cell exists and at which time step. And we construct this edge list where we have the edge source, edge destination, and the edge time. And it has two edge types, which is spatial proximity, which is like the using the Euclidean distance, and then lineage edges, like from where to where it's getting, like the parent and the daughter's cells. So this was the dataset layer, which I implemented the last week. So basically, for I'm using PyTorch geometric. So to make it work, I had to make all the cells at a basically equal size, like tensor shapes, so that I could input it into the PyTorch geometric. So I had to pad it into for zeros which don't exist in that embryo, and the data object contains the X alive, mask, edge index, edge time, and index to cell, like a number which is for each cell name, and also the source file which it traces back to in the Epic dataset. So this is what I prepared for this week. The data loader will give these files to the SGL model, which has three phases, which is the EAM, which is the attention module, the DRL, which is the dynamic relation learning, which is about the edges of the nodes, and DNL, which is the node itself and how it changes across the time. So the EAM, I'm explaining each of them here. So this is the EAM, which is the model layer. So the phase one consists of the edge attention module, which contains, like, it's dividing the whole graph into subgraphs, and then each subgraph is having like, it's dividing the into subgraphs, and then it's dividing it again in the respect of the degrees which it has. So the more degrees says more importance each node will be having. So after that, it will produce a n comma n comma k plus 1. K plus 1 is the number of nested graphs that we have, and then it encodes how each edge is centrally structured in the whole graph and how important it is. So this is a small MLP which is in this layer, which is like k plus 1. K is equals to 11, which was given from the previous papers itself. So 12 to 32, which is the middle layer, and then 12 output layer, and it has a softmax, and it learns a softmax attention weights alpha over the k plus 1 layers per edge. So we have two modes in this also, like sparse and dense, which is like it calculates the score edges based on the original graph, and dense is the whole baseline cost, which is the it will take all the graphs in all the time steps and then calculate all the attention scores. So sparse mode is computationally better and not expensive enough. So after this will output an adjacency attention matrix of each edge or node along the time steps. This matrix will get into the dynamic relation learning after that, which consists of three gates. Now, which has update, reset, and candidate. So each is implemented over the rows and columns of the matrix, and then we have this masking strategy which avoids all the dynamic shapes and stuff. And so this is basically based on the edges we have. So as we know that we have to update each edge, yeah, like at each time step we have to update the edges because the cells die over time, and the candidate is supposed to, like, input more data accordingly as the time step goes by. And now the output from the dynamic relation learning is given into dynamic node learning, which takes into the data of each node and how many edges it has, and it will then define a score to each node, and then we have a node importance score which is given out of it. So the whole pipeline goes like the data loader gives the npz files or the files that we need. It goes into the attention matrix, which give us the attention score for each node, and then we have the DRL, which calculates the edge importance, and the DNL, which contains the node importance. And then we have all of this into a single score file, which we further can use to classify and stuff or visualize how important one node is. So I implemented this to DRL and the DNL modules, which I'll be putting into a pull request like today, tonight, or tomorrow, using like all the changes noted down in the pull request comment section. And so nextly, I have to configure all the training data, like the learning rate and different, like how many subsets do we want to use, those stuff. And I also a bit of buffer to see if any improvements can be applied or not, and also a blog for this week I'll be doing, and for the next week I'll continue on the training the data, and after that I can work on if any improvements are there, or I can work on the visualization after that. So yeah.
Okay. Well, that's great. I had a couple. So let me see. EAM. What does that stand for? What's the full name?
Edge attention module.
Okay. And so, what is this? Why is it called edge attention?
Because it calculates the attention scores from each edge. We have to see that as the time steps are moving towards the end, we have to see which which division matters the most to the final cell fate. So it will score each edge or each division like that.
So, an edge is equivalent to a division, or is it equivalent to something else?
It will take each edge as a node, basically.
Okay.
So each division is taken as a node and how it matters.
All right. And then what would we expect? Like, I mean, because your divisions are like happening. That's the temporal part. And then there's the spatial part of the graph. So what would be the, I guess I'm asking, what would be the edge that matters in the...
Okay. So basically these three phases that I talked about, the EAM, the DRL and the DNL. So the DRL handles the that temporal part basically. So DRL is the edges part, which handles which edge is getting destroyed and the which edge is constructed in the next time step. And the DNL is the node in specific, like which cell is losing which edge. So one is node centric and one is edge centric. So and EAM handles the attention mechanism of the whole thing. So it will score that which edge is the most important at which time step, or it will score it accordingly.
All right. And then the what is the so DNL and DRL are node centric then.
The DNL is node centric and the DRL is edge centric.
Oh, okay.
So
I
DRL
see.
means relation learning, so relation between two nodes. So that's an edge.
Okay. Yeah, and then so you're basically evaluating nodes and edges. The nodes being the cells, and then the edge being the division of events. And so then you're kind of evaluating that process and how it's important. The reason I ask this is because we do have this, we do have, in the C. elegans, the lineage tree is somewhat standardized. Like, you don't have a lot of variation in the, early on, you don't have a lot of variation in the tree, but sometimes you have these asymmetric divisions where one cell gives birth to one live cell and one dead cell, and then that's not part of the tree. Sometimes you have events where there'll be a differentiation event for one cell, and then they kind of give birth, or the in the tree, at least the way it's represented. And if you're using the Nikhil Bhatla data set, where he's the interactive C. elegans lineage tree, it's often denoted as just kind of like a transition from one differentiated cell to another. So like a lot of the epithelial cells will do that, where they're just kind of like they transform from one to the next to the next. So I mean, there are things like that, and I guess I wonder what this approach would uncover in terms of important edges and how that makes a difference.
So basically, at the end of this thing, we'll understand maybe as a heat map,
Okay.
understanding the cell fate. Maybe at the end of the cell lineage, we'll have a heat map, like which division mattered the most, or at this point, this led to this, making it explainable basically. So if at any point we can make it more explainable than it already is, using that attention or automating this whole thing, looking at patterns. That's the
Right.
ultimate goal for this.
Yeah, I think like having like a heat map summary is good. A lot of times in papers, you'll see like where you have the network and they plot it out, and it doesn't really give you a lot of information, but then you'll use like a heat map or some other map of like the connectivity or adjacency matrix, and then it'll have like this information kind of embedded in it. You can see it a little bit more, or you can point to places where like there's this area here where the values are higher or lower.
Mhm.
So I mean that's what I'm just thinking about, like if you were to present this later, what would be the take home messages, what would be the key graphs, how
Well,
would you
we will,
show this to
yeah,
people?
we will have a adjacency matrix like that. Module outputs at adjacency matrix itself, which is further used by the DNL and the DRL to see if the how the node is changing or the how the edges are changing. So we already have that adjacency attention matrix over there, and then the DNL and the DRL basically are inputting more information about the edges and the nodes in that time step.
All right, thank you. Mehul had a question. I think you've already queued him up.
Yeah. I have few more questions, bunch actually. So yeah, I am a little out of context since I'm joining after a long time. I have what is subgraph exactly? Nested subgraph exactly here? You
So
mentioned k plus one.
So basically, every node is not connected to the lot of edges, right? So one node will have less number of edges or less number of degree in degree out degrees. So basically, it divides, like it takes out the nodes which have less number of edges at a first phase, and they have these phases where they continuously take out the nodes which have the least number of edges, and then it scores them accordingly. Like phase one, this is the score of each node. Phase two, this is the score of each node after taking out the least uh, degree node from that. So these are the subgraphs.
Okay, so like you basically some nodes are sparser in terms of connectivity. You
Yeah,
take them
sparser.
out in edges, and then those are formed as a subgraph. Is it like
Yes,
that?
yes, yes.
Okay, what is the purpose? Like, why are we exactly doing it? Like, very interesting thing, but what is the intent?
After removing those nodes, I think the attention scores change for the other nodes. So maybe that's some way it noted in the paper that this is how that module itself worked, the EAM module for graphs. So that was a part of the module
Okay,
which made it.
got it. A couple more questions I have. So you have mentioned sparse and dense somewhere. I missed it. I'm sorry.
Mhm.
With what respect is it like sparse and dense in terms of like number of connections they have?
Yes, person. Yes, number of connections. Yes.
So, like you also mentioned global and local somewhere
Yeah.
along the lines.
So global and local are the modes of the data loader. So if I want to analyze a single embryo, so that is a local mode, which is by the data loader, the information will be passed that way. And the global mode is analyzing all the embryos in the EPIC dataset. So that's if I want to analyze a single embryo, that is a local mode, which is centric on a single embryo, and the global mode will take in account of all the embryos and then produce a result.
Okay.
That's
So
a
if there
that's the
are
data loaders.
understood. So a few more questions, like you can let me know if they are like very relevant to this or not.
Mhm.
So if all the embryo data is there together, is it like a transductive setting in which like there are maybe not transductive also, like are there like is there a relation between multiple embryos together? Like a single embryo will have intra network connections definitely, but what
Mhm.
about different embryos together? Are there like islands or do they have interconnections between them as well?
I mean, there'll be difference in cell divisions, like when they divide and how they divide, which is like the cell fate is different for each embryo. So I think the comparison over there will play an analysis role.
Okay, okay, okay. Yeah, thanks. Those are questions.
All right. Yeah, so thank you, Mehul. Any other questions?
this is the module part, so it was a bit, it's a lot
Oh
uh,
yeah.
to take in. Yes. So next time, I guess I'll
Well,
bring some visualizations and make it look good.
yeah, I mean, you can't go wrong with visualizations. And then, just making sure that we know every part of it. Because right now, what you're doing is you're taking everything from your proposal and you're kind of implementing it. And, seeing how that actually looks is, going to be interesting. I mean, you might think about just running the code and showing some output as like a stand in for, like, okay, I can get this to run. This is kind of what it looks like. And then we can, I mean, I don't know how much we can say about it, but just to make sure that it's kind of like a sanity check when you if
Yeah.
you're doing work and you're like, oh, this works, but I don't know what it's actually doing or what it means. And so that helps us to see. So when you get to the whole thing, then it makes sense and it works.
Yeah, I thought about putting the code snippets as well, like the functions, like the specific functions, like which is dealing up to that. But yeah, I should have put those also.
Yeah, you might.
uh,
So you have it in a notebook now.
yeah, it's in a notebook, but I haven't run anything. Like it's just there.
Okay. Oh, yeah. I mean, you might, if you have time, you might think about creating standalone functions because we might use it
Hmm.
for, like I said, Devo learn or whatever other
Yeah,
purpose. Yeah.
maybe the dataset loader I can transform it into a standalone function as well.
Okay, that's good. All right. So yeah, I look forward to your pull request. And then Mehul said, yeah, he'd be happy to look over your code too if you want to go over code with him. And I think that's a good step because just to make sure that everything is the way it should be or that it works.
Hmm.
Yeah. All right. Well, thank you, Barshan, for that.
Thank you.
Okay. Looks like Morgan joined us as well. Welcome. So yeah, I guess Jess or Kavya, I guess I don't know if you had an update for us, if you had anything you wanted to mention.
Yeah, so last week as we were told to search on some papers and analyze some gaps and accordingly propose something. So I've sent a rough idea or a doc on Slack to you as well as to Jesse.
Okay. Yeah, we'll take a look at that. Thank you. Yeah, make sure. Yeah, and the Slack. What channel? Just the GSoC channel.
Actually, I have sent on the personal Slack too.
Okay. We'll check that out. All right. Thank you. So Jesse, yeah, I guess you
I
can go
would
ahead and.
encourage you to start in the group chat as well, just because I think this might be something that I know Ashu's not here today, but I think it's something that she mentioned being interested in doing too. So I'm interested in refining the project a bit more and seeing if it's something that people want to do. I think there's something there.
All right. Now it looks like Morgan is on the streets of San Francisco. What's going on?
Yeah, just heading in actually. Yeah. It's like first days of summer for our daughter. So a little change in schedule.
Yeah. Yeah.
But um yeah, been working on again some of the MudArc uh, projects, which is just again like interesting to go through uh, to be kind of using multiple medical imaging foundation models and seeing, how in many cases just how poorly they're doing relative to classical ML.
Oh, really?
Yeah, yeah, yeah. Um, so this comes back to this question of like, are there ways to analyze the weights itself to get at the fact that like, are these undertrained, are these poorly trained? Sorry, my tram is coming.
Okay.
Checking in.
Oh, thank you. Yeah, that's good. Yeah, so thank you for that update. So I have a feature today on sort of the evolution of repositories. So what does that mean? So I'm going to talk a little bit about how when we start a project, and we talked about this with respect to open source sustainability. A lot of times when we start a project, we have a repository and we give it a name. And then we get like, maybe some collaborators in the mix and they start contributing. And then over time, maybe 2 or 3 years in, the project changes. Maybe it scales up to new contributors. Maybe it changes its identity. We often see this with where small projects will name themselves one thing and then they'll kind of adopt a name, maybe if they become like a more formal organization or company or something. And so we want to be able to track those changes and we want to be able to make sure our repositories are in sync. Not just if we like make a bunch of forks and those forks are all out of sync, which is another problem. But also that they're in sync with what we're doing in our projects, what we're doing in our organizations. And I think that's maybe one of the worst problems in open source that people don't talk about, is just keeping things in sync. So, let's talk about like forks for a minute. So if we have a bunch of forks, like let's say we have a project and we have like 10 forks, keeping those forks together is really, it's if I make a fork, I make a copy of your repository, but it doesn't automatically sync, and nor should it, because I want to build things on my own. Kind of the reason I make a fork is because I want to build things on my own and distinguish it maybe from a branch. So if I just make a branch, I'm usually maybe like testing something, or I'm doing it as like a working directory. I'm making a separate thing that I can commit to, and I don't have to commit to the main repository. So I don't have to go through all the administrative channels of a maintainer, or sometimes I don't want things public. I want to try things out. And that's all kind of branch strategy stuff. Now there's of course this debate whether we should do branch development or fork development, which I'm not going to talk about today. But that is a thing where people say, well, if we really want to have a development team that's effective, we need to everyone should have their own branch. They should kind of do their own contributions on that branch. And then when they're ready, they're sort of at the production stage, they merge it with the main repository, the main branch, and then it goes into production. Other people think, we should fork everything and we should maintain our own forks. And we should then merge back to main, or to the main organization or repository when we go into production. And then, of course, if you're an open source org, a lot of times you're not doing this in the context of production. You're doing it in the context of when I'm ready to do this. So that makes it a little harder to synchronize. But in any case, this synchronization, if I make a fork and I make a copy, I can synchronize that fork. But sometimes it's very hard to know when to do that. And sometimes you're making so many changes upstream or downstream that it becomes almost impossible to really synchronize it without maybe doing damage to what you're trying to do or whatever. So that's kind of what I want to get into, the evolution of like open source repositories and things like that. And I think it's a valuable topic because we don't think enough about that change over time. And I know, like in the case of like Devo Worm, I should say, we one time just had the Devo Worm GitHub account, and we had everything there. And then around 2020, we made the Devo Learn organization, which is where we started doing this development for the Devo Learn software. And then eventually we started to do Devo Graph development in that organization. So we started doing that. And then that repository that's in the organization has changed so that now, we have to kind of go back and make changes to nomenclature, make changes to things like that. So it's like tidying up things, but it's also like keeping things in sync with where you are today. And so, as you can imagine, anytime you have that situation, you're going to have these atavisms that pop up. And an atavism is just simply something that is a remnant of a past state or a past regime. So if you notice in the Devo graph repository, we have these stages, which we don't really refer to anymore, but basically it was something we did when we started that repository that was like, okay, stage 1 is image processing, stage 2 is building a graph, stage 3 is visualizing it. And since then, we've kind of had projects or kind of had contributions and contributors who've kind of gone outside of that nomenclature. And so it doesn't necessarily make sense, but it's still there in the repository. And I'm loath to get rid of it because it actually still is useful. But in our everyday conversations, we don't talk about it. It doesn't make sense necessarily. So that's the kind of thing I'm getting at here. Now, I want to make a little note here in that on Monday, and this is a saga that goes beyond this week, but on Monday we had our Orthogonal Research and Education Lab organization restored by GitHub. So the story here is that several weeks ago, the organization was deleted. It was not done intentionally. It was upon investigation, I think, and no one can confirm this, but it was some sort of malicious attack where they used someone who was in the org, or they didn't actually, I don't think they actually had permissions to do this, but somehow someone got access to an account that was associated with the org, and they deleted the org, which is, a pretty big problem. Yeah. So, and we hadn't backed up what we had wanted to back up on it. We had some repositories that were forked and some that weren't. So I tried to I filed a ticket with GitHub. I tried to reconstruct everything. Actually, it gave me an opportunity to reconstruct one of our repos to a new state, which is actually quite, it was a, kind of an opportunity. But then this Monday, we got this restored. So we got this org restored. And it looks like what they do when they restore an org is they take, I guess I don't know, it says that these are forked from different places, but the contents are sort of what they were when the org was deleted. So I'm not really sure how that works. Maybe they just find like a template and then they update the info. So some of these things were forked from sort of maybe the last person to commit to this or to fork it. And so that kind of makes it even harder to synchronize. But anyways, like this one is our Saturday morning meetings. Now, fortunately, we had forks of many of these repositories. So they weren't, they were in different places in different states. So I could go back and find like, parts of that, maybe it wasn't like the last comment or the last pull request that was made, but it was close. So I had all of that information. But anyways, we got this restored this week. So it was a saga in that, first of all, that this can be pretty, we can have problems like this that happen in your organization. You need to be able to deal with them. And I've come up with some strategies for being a little bit more proactive in terms of backing things up. You should always back up your repositories and, make sure that they're in a current state. A lot of times if you make a fork, like this fork, this was forked from DevoWorm Saturday Morning NeuroSim. I had a fork out there I made about a year and a half ago. Now this branch is 359 commits ahead of this. So I wouldn't want to sync it to that, but I'm not entirely sure how we sync them. You have to really do some mental math and some kind of figuring out where things are, what you want to have synced and what you don't, to make that work. So that's kind of one of the problems with like keeping things current, and especially when you have something like this happen. So I've like Jesse was asking me about this, and he said, "Well, why is it that? What do we need to do differently?" And I kind of come up with some ideas about like just really keeping the number of contributors just very core, and then like everyone else is kind of an external person, and then we also have some things about backing up assets and things like that. So it's just like you clone the repository to keep it in a folder or something. So yeah, this is a lot of like maintenance stuff, but I think it's important to know, like from an organizational standpoint, how do we deal with these things? Okay, so enough about that. I want to go to these articles that I found. So this is an article. I don't remember where I got this from. This is Stefan Hiller from 2024. Maybe it's his personal blog on exploring repository architecture strategy. So again, this is about like, how do you represent a project? And so, it's tempting to say, well, we just create a repo. But it's like, what do you mean by one repo? Is it a repo? Or is it an org? Or is it like multiple repos? Or it could be multiple orgs. I mean, depending on what you're trying to do. There's part of it is sort of the efficiency of storing the code. So if I'm an open source contributor, I can go to that repo and say, this is everything I need to run something. I can clone that repo, run it from the clone. I can fork that repo. I have everything I need to do to contribute. So I don't need to have like multiple repositories forked and then have to synchronize all of them. And it's a mess. You have to kind of think about that. You have to think what makes this easy for people to interact or interface with it, but also kind of for your org. What is it that you need to do to maintain things, and what's the best strategy for maintainers who need to accept pull requests? What's the best strategy for people who can go back and refactor the repository? So this repository is not optimal, I would say, but it kind of serves the needs of what we're trying to do in this repository, which is to create a sort of an archive of meetings, and week by week. So this goes back to 2020, and you can just click on this README, and it has all of the links here, and this is all basically to YouTube links and other assets, but it works for what we want to do. Now, that's something that you could update, you could make it better, but, and you could make it more optimal, but that's, something that is for what we want to do is fine. All right. So, but then we could also create other repos around that, and we could link them together. So you have to kind of come up with a good strategy for what you want to do. And if we were developing software based on our meetings, we might create another repo. It would look very different from this. So the scenario overview in this article is that the choice between a monorepo or monolithic repository and a polyrepo or multiple repositories is a critical decision for software development teams. This decision can significantly impact workflow, collaboration, and scalability. In this article, we explore the advantages and disadvantages of both approaches, helping teams determine the best strategy for their specific needs. So imagine a mid-sized technology company which is developing a suite of interconnected applications. These applications include a web platform, a mobile app, and several microservices supporting the backend. So you have all these different things going on that you need to have in a GitHub repo. It's not necessarily open source, but you want to manage the code. So for the monorepo strategy, which is where everything is in one repo, you have the advantage of a unified code base, consistent development workflow, so you can use the same tools and processes across the project, and it doesn't require you to set up so many workflows that you don't know which ones you have and which ones you don't. simplified dependency management, so you can share libraries and dependencies, and then atomic changes, which is where you can make changes in a single commit that affect multiple parts of the system, ensuring compatibility and reducing integration issues. Now, the disadvantages include scalability issues. So again, like we said, if your organization scales up, it may slow down a lot of things going on in that repo. You might overburden your maintainer. These continuous integration, continuous deployment processes might become slow or hard to implement, and harder to implement as you scale up the number of people in your team, or the number of forks that you're using. Another disadvantage is complexity and access control. So this is where you need to manage permissions. This is one of the things that we were doing in the org that was like so challenging, is to manage permissions. And I think it's one thing to have like give people permissions, but I guess I never gave anyone permission to delete the repo or delete the org, but it happened because people had people with maybe non-active GitHub accounts. Maybe they stopped using GitHub for some reason, and you can get hacked, and all sorts of eventualities can happen. But anyways, when you have large teams, that complexity grows.
So I have a little quip to say here, and it's
Okay.
from a very, very, very old web designer friend of mine. Actually, my first ever web designer friend. So talking like 15, 20 years ago. And it gets weirder when you, like Bradley's talking about scaling and big projects organizations. So it's not quite as easy as what I'm about to say, but especially for a lot of people here who are solo or like building small teams or whatever, it applies, I think, pretty directly. And the old saying is, if it doesn't exist in 3 places, like your software or your project, it doesn't exist at all because of the backup reason. Like if you don't have it in like multiple storage locations, some of you update all the time, some of you do longer periods, it doesn't exist.
Yeah.
So I think it's just it's a little pithy and kind of like, but it's something to keep in mind when you're not going to want to think about it, especially when you're like changing stuff or like if you're migrating. Like I just did a huge website upgrade for the whole organization, and it's like you don't really want to think about it during that time, but it's more important to think about it when it's like the least inconvenient to do stuff. So
Yeah.
that's all. We can go back to the other. Yeah.
Oh yeah, definitely the strategies that you have to practice over time. Like you have to be persistent. So you can't just back things up in 3 places once and then leave it there. You have to do it every 6 months maybe. And
Yeah.
that ensures that you capture all the changes happening.
And I think like it's a double, like this is sort of an interesting point to look at, like the kind of what this is happening on many different fronts right now, where like using AI here, using Claude, using whatever, the Claude Code or Claude Cowork or whatever, and it's like it can be a little bit deceiving, thinking, oh well, I'm just telling this person to do thing, and I might even say put in some kind of a script or a skill or some kind of an instruction to do a backup regularly, or we're going to use branches when we're pushing the code or making pull to your repo. But like even then, it's like this is a conversation we had in one of the data and direction folks yesterday, was basically about unexpected things happening when you're handing off to human interaction, or like when you're breaking a cycle of AI automated sequences or whatnot. Like what can happen, and how does both the human and the AI like collect for, hey, something should be happening in the sequence of events, but it does or doesn't. So I guess what I'm saying here about the backup process, excuse me, is what I'm saying here about the backup process is there are I find to be very blunt, I think part of my own coding practice of making branches, making really good commits that are clear, and trying to like making good demarcation to your documentations of like, hey, here's things that you probably won't think are consequential at all now, but maybe a big deal in like a week and a half when you don't, your context has totally changed. I think my overall practice has gotten better, but at the same time, I've learned to develop this sort of um, intuition about like, okay, as much as I'm feeling confident about things, it's like your internal timer. Like you basically have to go and check to realize, wait, here's the existing flow that I think is executing what I want it to do. But let's go back and and like especially now with all of this, I find it easy if I sort of intuitionally think that to like the rapid updates that are like everything's updating all the time now. So I basically just try to associate it with that somewhat. Like when I'm seeing updates, I think, okay, what do I need to update that's extended to this or that's part of my workflow? And I think a core thing is maintenance, security, documentation, like the not fun, the not sexy things that will, if there's a major flaw there, will collapse everything. So I will leave it at that. But I think this is, I'm really glad that one, I'm really glad the organizational the org and all of its repos are back, because that was huge, 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 and I think we're doing the right steps about that, and you know um, more about that later. But two, like I think this is I think this is going to be increasingly a topic, because one, you can get malicious attacks, or like we don't have to talk about this now, but it'd be something for next time. Is like people, there's a lot of pressure now to not like. It's so easy if you have access to certain things, have get the data and have Claude make their own version of it tomorrow. And like the pressure to be selective about what you're showing and being mindful about what's public or not that way, like that's a whole new like that ball game is changing now. So maybe more about that next time. But I think this is great that we've talked about this as a core thing to be concerned about here, as we're making software and related things.
So yeah, back to the article. Yeah. So then, of course, there's this potential for merge conflicts. So if you all work on the same repo, you can have a lot of collisions in terms of merges and things like that. If you've ever done anything with a bunch of collaborators, more than like three, you know that like a lot of times if they're working on the same doc, you have a lot of things that you need to go back and manually approve. But sometimes it's hard to know like which things are the right things and which things are not. So it's a hard thing to kind of manage. And then of course circular dependencies, where it's easy to introduce undetected circular dependencies by developers when you have a lot of things going on, and you automatically just kind of have this mentality, I'm just going to accept this work and not check every dependency. So that contrasts with the polyrepo strategy, and the advantages there is that we have scalability. So we have these smaller focused repositories that we can manage more easily. We have clear separation of concerns, so every repository might be dedicated to a specific component. So for like in Barshan's case, he might have repos for some of the functions, or maybe two repos for the maybe three repos for the project, each focusing on different phases. I'm not saying you do that now, but this would be an example of how this would work, where you just have very small chunks and you're maintaining it at smaller scales overall. Then they're tailored workflows. So if you have smaller focused repositories, you can customize workflows and tools so they work better. They're more tailored to what you're doing. And then improve security and access control. So if you have fewer people have permissions in a repo, then it's easier to manage those that access and making sure that nothing happens that is bad. Then there are disadvantages. So the disadvantages here are dependency management complexity. So again, you have to manage these small repositories in an inter-repository way. So you have to see, if your project is divided up into 5 repositories, those things, if you want to run the whole project, you have to make sure they work together. And if you're developing in different repositories, sometimes you can't do that. So you may need to spend more time on that. Cross-repository changes, of course, are a problem because, of course, you don't always develop in a siloed way. You're sometimes developing things that go across repositories, and it's harder to make successfully synchronous changes that way. And then, of course, you end up with a fragmented code base, or you have the potential to do so, where the code base is spread across multiple repositories, which can make it harder to get a holistic view of what you're doing. So that's kind of the thing. And so each one has positives and negatives. He gives some key design strategies here. He gives some examples for each strategy, the mono repo and the poly repo strategy. He gives I think probably 10 different key design strategies. So basically, you should think about project modularity. How can you modularize your project without suffering from the sort of siloing effect? Make sure that you're on top of dependency management. There are tools you can use to overcome some of the limitations of both the monorepo and the polyrepo approach. You have to have a good set of version control practices, and that's true anywhere, but especially when you kind of think about, if you have, say, like a trunk-based strategy, it's a very different set of version control practices from forking strategy. And so that's just something you have to think through as an org. You also want to have continuous integration and continuous development and kind of leverage that as appropriate. You'll do a lot of code quality and testing, and that's, of course, different for each strategy. So you want to make sure exactly, you have a good protocol for that worked out. Having documentation and communication in the right places. Having good access control and security. Having a strategy or having a good handle on change management and release strategies. So how do you manage change? How do you manage different releases? Then scalability and performance optimization, and then finally tooling and automation. So he gives a lot of thought into that. This is a paper, and I just want to mention it because I don't think we need to get into it a lot. But basically, this is a nice paper from the archive on a tool called GitEvolve. And GitEvolve is predicting the evolution of GitHub repositories. So they're looking at GitHub repositories, and they want to be able to predict how these repositories evolve over time. So I'll go over the abstract, and then we'll talk. Well, I think we're getting towards the top of the hour, so maybe we'll have a little discussion about it. So the abstract reads, software development is becoming increasingly open and collaborative with the advent of platforms such as GitHub. Given its crucial role, there is a need to better understand and model the dynamics of GitHub as a social platform. Previous work has mostly considered the dynamics of traditional social networking sites like Twitter and Facebook. We propose GitEvolve, a system to predict the evolution of GitHub repositories and the different ways by which users interact with them. To this end, we develop an end-to-end multitask sequential deep neural network that given some seed events, simultaneously predicts which user group is next going to interact with a given repository, what the type of interaction is, and when it happens. So this is basically where they're saying, given some conditions, what kinds of repositories or repository strategies make it more likely that people will interact with your repo, and then how will they be interacting? Okay, so to facilitate learning, we use graph-based representation learning to encode relationships between repositories. We map users to groups by modeling common interests to better predict popularity and to generalize to unseen users during inference. We introduce an artificial event type to better model varying levels of activity of repositories in the dataset. The proposed multitask architecture is generic and can be extended to model information diffusion in other social networks. In a series of experiments, we demonstrate the effectiveness of the proposed model using multiple metrics and baselines. Qualitative analysis of the model's ability to predict popularity and forecast trends proves its ability. So this might be like from SIGCHI or somewhere. But basically, they're building this predictive model so that you can look at your repository, you can adopt a strategy ahead of time that maximizes people interacting with your repository. So they kind of give a bunch of information about how GitHub works. And remember, they're coming at this as kind of like a social network perspective. So, of course, GitHub is social coding, right? It's not just a place to store code. Although, we don't think of it like that. Usually, if we're doing like an open source project, we just think, okay, here's the code, people can go use it. But really, this is a social activity, and it's a collective social activity at that, where people are interacting over time. There are changes that are made because people are interacting with it, and you have to, sort of manage that from the top down because that process of evolution is bottom up, and you have to synchronize those over time. So they have their different, their training, their simulation, and then just thinking about how people interact with the different components of the repo. And then you have this model, which is shown here. So I'm not going to get deeply into that, but I just wanted to go over that paper. So that's sort of an encapsulation, maybe sort of an open source sustainability type approach to thinking about the evolution of GitHub repositories. Yeah. Actually, Jesse mentioned something in the chat. Build your career as if degrees will lose their value over time. And then Barshan had a question. What about authentication methods like two-factor where someone is trying to delete the repo? Yeah, I mean, GitHub has like access, which you should be able, if you're getting into an account or something, or ways to like manage permissions. I mean, they do have that, but I don't know if it was like someone found a shortcut around that or if like there was something else going on. I just don't know. But I think it's best to be proactive. So in case like, those sorts of things happen, then you can, you're protected for your own purposes. You don't have to worry about like problems with the platform. Because we had this problem with Canvas, which is a course management system earlier this year, where someone hacked into the company's database, and they basically took the entire thing offline for many, many universities that adopted the platform. And so it was because it was during finals week for a lot of universities, it was a huge problem. And that's not something that you can control. But what you can do is you can build in redundancies that help to safeguard yourself against those disruptions. Yeah.
Yeah. I don't know how much more time we have today. I'm gonna once again table any like how do you do the speaking presentation stuff until maybe next time. But if we have a few minutes, I might just cover some of the points there.
Yeah.
But I don't know, Zato, you guys want to do that?
Yeah.
Okay. So there's two things I'll cover right now in sort of an abridged, getting some nice nuggets out there. One of them is about job advice in general. And one of them is about, we had a question come up. Barshan mentioned it at some point. It's come up a lot in many people have been talked to, like, young folks. So the young folks dilemma of what do you do with your career right now? What is the value of a degree and all that stuff? And I'm curious. I kind of my initial response when it came up earlier today was a particular way. I thought about it a bit more, and I'm curious. I don't know if Bradley or Morgan or other folks have like thoughts about it, but my general sense on it is basically the question of like how much is the degree worth it going forward. And what I just put in chat was basically operate like your degree is something that will not hold its value long term. But what I said in a more what I tried to in my slightly more, that's a little bit more hot take. What I said earlier today, and I think I'd open this up for discussion, is basically I think when we think about degrees, I think the questions like, do I pursue a degree, or do I pursue a graduate degree or not? I think it really comes down like things you should look at when you're evaluating that should be time, like basically costs and benefits, but in terms of money spent, but also the time you're going to be asked to commit to doing something. If you have a like very obvious no's would be long degrees that are very expensive and aren't really about anything you would particularly want to do. That's like that seems like okay. There's no point to do that unless the only thing that might be is like strategically if you need to get a degree because you want to relocate for various reasons. Like there's other like indirect reasons to pursue that for some people. But for just career development, maybe not, unless like relocating or getting your foot in a door somewhere else. Like the reality is for a long time now, finishing your PhD in computer science is like not a big deal. like a lot of people go, oh, I got in, blah, 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 and then they drop out a month, or like a year, within a year's time. Like that trend's been coming for a long time, particularly in certain technical spaces. Now, I'm not advocating you don't do that, but I just feel like really being strategic and thinking what are the current ways value is seen now. And I think the most important thing is like whatever you are, whether it's a job, in the job sense, there's like the saying, like you're either earning or you're learning kind of a thing, or maybe there was another one too, but like, unless you're progressing a skill and having something to show for it, whether it's a career or a degree, you know, that's a useful lens to look at. Is like, what are you actually developing and getting some kind of a portfolio or artifact or thing. You say, during this time, I did blank, and here's what I can show for it, and here's what I can build on it. That's sort of the core. But I'm open to like other commentary because we're all kind of in different points of view about that and locations. So
Yeah, I mean, I guess a degree losing its value is kind of relative, right? I mean, like the argument for a lot of degrees is it helps you to be able to think and transfer skills and things like that, which is, you know, if you think about training, that's kind of the, you know, if you find a degree that, like, if you got trained just to be like a Pascal programmer, you know, at one time that was pretty valuable, but now it's not so much. Although now, you know, if you have legacy code written in Pascal, you might be the only person to know how to use it. So, but like, you know, it depends on sort of what you're learning in the degree program. So yeah, it's but yeah, and you get like different types of degrees that become very hot and then they cool off. You know, this goes in cycles. Computer science has done this before where you get like, you know, maybe a recession or something where it's no longer as valuable, but then it ramps up after a while because maybe the number of majors falls. If you go back to the data, you'll see this where there's like this cycle of different degrees that are awarded, and you know, people will rush into a degree program because it's hot, because there's some interest in it, and then it cools off. And so, I mean, you know, the whole idea here is that it's like, you know, some people might recommend, well, you pick the best degree for the times, but then the times change. So it's really hard to know kind of what the best degree is. So there are all sorts of arguments here. I don't know. I'm not going to give you an answer that's definitive, but
yeah, and I know we can come back to this later. I'll just to get to the other topic quickly. I think this is a really cool. I think cool is not the right word. I thought this was a useful thing to think about. So Ethan Mollick, who I know he's like got a bunch of followers and it's almost cliche. He looks like someone, oh, he's just a big name. I think the thing about Ethan, he's really in the trenches about latest model developments and how it affects career stuff. So I really would recommend following him. If you're someone who's stepping into the arena around technology, what's this latest model doing? He's not the only perspective you should have, but like the thing he brings up consistently, I think, are pretty of high value. So this comment that I have here is, oh, yes, show me what I'm showing. just he turns off my screen sometimes. This comment here I think is really good, and I try to elaborate on it. Sometimes I'm like, oh, should I say my piece or not? But here it's like, what's the token uses? And I don't think we should be seeking high token jobs. I think it's a great question to diagnostic, like this ping in the spider web, or if you go, drop the pebble in the pond and see where the ripples go. Like you can tell if they're prepared for that. If they're like tokens, what do you mean like you can get a lot by how they'll handle that. And I think it's a nice question to ask, um, especially if you're not quite sure what the organization is or does. And a lot of us picking up like startup type jobs, or like if you go to Anthropic, they're how they're going to reference token is pretty obvious to you. But if you're unsure of an organization or a role or direct, like who's a supervisor leading a team, these kind of things are going to be interesting for you to get a sense of. And I think that's something that absolutely I would advise anyone, um, to have in your pocket. Like it's a great, people always say, oh, what are the questions you should ask the interviewers? I think this is a fine one to ask right now, even if they have no response or you're not really encoding, like I think it's just a great sense of like where their take on you, and also the AI workforce that is maybe replacing you or working with you, or their expectations. Like I think you've seen like a compliment to this would be, I think it was Jensen Huang, Mr. NVIDIA, or someone similar to him saying, when I hire a senior engineer or a senior person here, they better be using all their tokens in their job because I'm giving them the allocation to do it. Right? That's at a very particular lab structure with a very particular take on AI and a pro AI usage and so on and so forth for LLMs and tokens and whatnot. So it's like you're going to be in different arenas where those things are changing, or those norms are not unique. So I think learning how to that's sort of the new, like no one's ever been taught, hey, how do you talk to your future employer about AI token usage in your job? Like that never came up in my education for a variety of reasons. But that's like de facto the topic of the day, that will come up. So I'll leave it at that. Any follow-ups or things? I know we're kind of out of time. So, yeah.
Just to say, I see. I think the conversation that you have with your employer should be, um, you should have questions, and asking them, uh, asking them unusual questions is a good way to find out, how they do see you. Like being able to uncover how they do see you is a good, um, litmus test for, whether you are entering into a toxic culture or not.
Yeah.
Um, uh, the reason that tech companies are laying off people is because their balance sheets are insane right now, and they can't afford to pay programmers when they are selling their business to fund data centers. You know, it's nothing. It's not a productivity story. It's a I would say it's a business finance story. You know, um, but you know, questions about how you're going to be treated should be number one. And you know, I just say that, like, I see, you know, degrees and a lot of the kind of, it's a little like YC, where it's just like, it's not so much the skills, it's not so much to having the degree, it's like what did you do with that 4 years, you know? So it's like using it as a chance to show, like, when given opportunities, this is what you do with them, you know. That's just like a couple things. Yeah.
Yes, and if we have a few minutes, Bradley, or we got to go right
Yeah,
now?
yeah, we can go ahead. Yeah.
Okay, cool. Really great points that I would double down on with what Morgan said. One, like and I would love to, like, I'm making some materials around this. Like, one of the most important things you can do as a career person, especially early career folks, you need to be incredibly, for lack of better terms, I don't want to use words like aggressive, thirsty is kind of weird here, but like, you need to have a very clear hunger and desire to understand organizationally where you're fitting in and who is doing what. And this can be a university lab, this can be a nonprofit organization. Your goal is to see what your, both from a top down and a bottom up, how your role, not, and basically not dehumanizingly so, but like how you as a, what your position, your impersonal role is supposed to do, and how, what are the top down pressures on that, and the bottom up or like sideways pressures affecting what that is. And that's it. Every organization is somewhat unique to that end, but over time you develop an intuition of, okay, a lot of university labs like this, a lot of smaller groups like this, a lot of big groups are like that. That process, like, I almost want to make a frontier map of what that process is, if you will, because like that's like the, I'm kind of relying on my D&D stuff here, but like that is the wisdom stat. Like, that is your ability to discern insight about the direction of your role in the company, is how much you need to know that to evaluate a lot of other factors that are coming up indirectly in an organization. So I call this like organizational literacy, or like organizational structure literacy, or whatever. I'm fleshing out what to call it specifically, but yes to that. And also, like, what Morgan said about how you're using the 4 years, or what YC looks at, or other things. Yeah, I think that's maybe a better way to say what I was trying to get at, which is essentially, the way I look at it now, and even in things that I'm doing at my own scale, is sort of, what is someone doing relative to the opportunities that they have? And it's less about kind of yes, there's an absolute scale of like, it's great if you have this number of, yes, publications or projects that you can show in a portfolio, and more of a certain quality is better than less of a lesser quality. Yes. But like, what are you doing with the time there? And also, I think, for things like YC or other accelerator programs, which is different than a career job, which is different than getting into a lab. These are all kind of different things. Like, for the pitching, venture capital, whatever, having a really compelling thesis of, I don't want to say seeming like a winner, but like having something that you're building that's like cultivating a line of successes towards a particular thing, is unique to that space. That's not the same as developing a career in a tech space, or the same as progressing in the old academic ladder or the new academic ladder. They're kind of is it all success? Yes, but like how you convey and present it is totally unique. So kind of like finding that. But the common theme, I think, of increasingly there's I don't want to say a portfolio based world, but I think the most valuable things are people that are willing to grow and change. Like I feel really I feel really I think people that are very disadvantaged in the world right now are people who are kind of just catching up to like one of my friends, a very brilliant person, a bioinformatician, didn't use AI for a long time. And then like in the last year, since he's been teaching a course to a local school, university, or like being a TA or like kind of more than a TA at that course with a professor, there was when he first started doing that course, I don't use LLMs at all what I'm doing because it's so niche and what I'm doing, there's no applications there. So he's kind of catching up to that now, where the professors was like, well, actually you can use it this way now. So I think there's sort of this emerging trajectories of using the technology and just getting used to it. I think the last thing I'll say about this, I think it's incredibly popular in a lot of obvious ways. Flashing your AI familiarity credentials right now is hot, but it is changing slightly. Like the backlash stuff is there, but I think what's more important to do is to identify yourself as a sober evaluator and user of, hey, I'm kind of with this stuff. I know about it. I've built some real things that show I can do this, but I'm also not tying myself to the mast of I'm Gen AI everything I do, and like maybe some places you do want to be. I'm AI native AF. I'm AI native about everything I do, and that's the right way to pitch yourself in certain spaces. But I kind of advocate for a little balance and sobriety there. Um, I'll leave it at that. There's a lot more to say, but I think this is the stuff everybody has questions about what they do, you know, and I think the answer is it's really there's general truths and some niches, some niche stuff to pursue as well. And then I pulled up. We're not going to go over this, but now, but like if you want more on the thing that Morgan said about why they're making cuts and laying people off, this is a little bit of commentary to that end that I wrote a few months ago and still mostly is applicable. So you check that out. The end.
All right. Yeah, thanks. So when I was 10 years old, I worried about like video game tokens and my budget for that. So we've come full circle. All right. Yeah. So thank you, Jesse, for that, and Morgan and Barshan for your questions. And we'll see you next week.
Yep.
Thank
And if
you.
you guys have questions about this stuff, please put them in the chat. We'll try to address them more next time too.
Yeah.
But take care, everybody.
Thanks.
Bye.
Take care. Bye.